Welcome back to the deep dive. So if you've been keeping an eye on the LLM world, it's been dominated by a few big names for a while now.
Right. OpenAI, Google, Anthropic. They've really set the standard, haven't they?
Exactly. But things are definitely shifting. And today we're digging into what looks like a major new challenger, particularly from China.
Zhipu AI, or ZAI as they're often called.
Yeah, with their new GLM-4.6 model, launched just recently, end of September 2025, according to the sources.
And ZAI, they're not exactly newcomers. They've been building this general language model, or GLM series for a bit.
Right.
Starting with things like Chat GLM-6B. But this 4.6 version, it really feels positioned differently, like a deliberate shot at competing with the top Western models.
It does. And that's what we want to unpack today, really cut through the usual hype around a big AI launch. We're going to use the source materials, the benchmarks, the papers, the independent tests to see what's actually verifiable.
And figure out what it really means strategically.
Yeah, and especially how this accessibility angle might start to democratize things a bit more in high-end AI.
Well, the sources suggest it's not just about power, it's about efficient power.
Okay.
And that combination, power plus affordability, that could really shake things up.
Let's start there then. Big picture. The sources say GLM 4.6 is aiming for versatility, right? Reasoning, coding, agent capabilities all rolled into one.
That's the idea, a unified model.
But the thing that really jumped out from the sources was this claim about efficiency.
Yeah, that seems to be the core architectural hook ZAI is pushing. They're calling it the most frugal model in its class.
And the numbers back that up.
Well, the documentation points to over 30% fewer tokens used compared to GLM 4.5, its direct predecessor.
Wow, 30%. That's significant, especially at scale. But hang on, we've seen budget models before that cut corners, right? Where the efficiency comes at the cost of, say, output quality or consistency. Are the sources clear this isn't happening here?
That's the million-dollar question, isn't it? The analysis suggests this efficiency stems from genuine architectural improvements, not just dialing down the quality knobs.
Okay.
And when you think about the biggest barrier for many, especially startups, being computational cost.
Right. Running millions of calls adds up fast.
Exactly. That 30% cut means much lower cloud bills. It potentially puts these advanced capabilities within reach for folks who were previously priced out.
So it's not just exclusive to the giants with huge infrastructure budgets anymore.
That seems to be the goal. And the accessibility push goes beyond just token cost.
You mean the open source aspect?
Yeah, making it available on Hugging Face is a big move. Plus, the managed API subscription starting at, what, $3 a month?
$3. That's incredibly aggressive pricing. It definitely plants a flag in that budget-conscious developer market.
It does. And it seems they believe the tech justifies that low price point.
Yeah.
Which brings us to the actual muscle behind it.
Okay, let's talk capabilities. If it's built for agents, memory is key. What's the context window situation?
It's staggering. 200,000 tokens.
200,000. Okay, put that in perspective for us. That's more than just reading a long book. Right?
Oh, absolutely. Think of it less like reading a novel and more like managing a complex week-long project.
Okay.
Where an assistant needs to research trends, draft different documents, handle logistics, maybe troubleshoot unexpected problems, all while remembering the original goal.
Right, so it's about maintaining that complex state and awareness over a long dynamic interaction, not just static recall.
Exactly that. Indispensable for those agentic tasks, where the model needs to break down big problems and maybe call on external tools step by step.
Makes sense. And you mentioned coding earlier. The sources really highlight coding as a standout feature. How does it stack up against the established players there?
It seems particularly strong on the front-end side. Generating code, say in Python, JavaScript, Java, that actually results in visually polished web pages with layouts that make sense, that are functional. It's trying to move beyond just spitting out back-end logic.
Oh, so not just functional code, but well-structured, almost product-ready components. How does it handle, like, modern libraries or tricky framework integrations compared to Copilot or maybe Claude?
That's where the testing comes in. According to the sources, in specific controlled tests, they mentioned 74 scenarios, some in environments like Claude Code.
Okay.
It actually outperformed rivals, like certain versions of Claude Sonnet, in generating usable, high-quality code.
Interesting. So winning on practical performance, not just theoretical benchmarks. What about the softer skills? Creativity, communication?
On the creative side, the claim is that its style is very close to natural human writing. Good for things needing nuance, maybe novels, scripts, sophisticated marketing stuff.
And translation. That's often a tricky area.
Right. And here the focus seems to be on handling informal language and maintaining semantic coherence.
So not just formal text, but slang, social media.
Exactly. Older models can really stumble there, even in major languages. GLM 4.6 is highlighted for keeping the meaning and flow intact, even in, say, Russian or Japanese, and crucially, handling that messy, real-world conversational stuff.
Those are some impressive claims, especially the coding and agentics, but like you said, the proof is in the pudding, or in this case, the benchmarks. Given how competitive this space is, what hard evidence did the sources point to?
ZAI seems to have put it through a pretty demanding gauntlet of standard benchmarks, not just their own internal stuff.
Like what specifically?
Things like AIM 25, that's advanced math, GPQA for expert-level questions, LCBV6 for logic, HLE for human-like evaluation.
Okay, sounds rigorous.
And, crucially, SW Bench verified. That one's key for judging real-world coding chunks objectively.
Right. And the results of all that testing, where does it actually land?
They position GLM 4.6 as basically the top Chinese model out there right now. And on general leaderboards, it's reportedly matching or even slightly beating Anthropic's Claude Sonnet 4.6.
Matching a frontier Western model is, well, that's a statement. But you mentioned cost earlier. The sources highlighted a huge cost difference, right?
Yes, independent tests apparently confirmed it beat Claude 4.5 Sonnet on real coding tasks, sometimes at like 10 times lower cost.
10 times cheaper. That completely changes the calculation for developers.
It really does, and it makes you wonder, right? Is that low cost purely down to genuine architectural efficiency? Did they just build a cheaper engine?
Or is it maybe a subsidized price to grab market share fast?
The sources suggest it's probably a mix, but lean towards architectural efficiency being the main driver for the token cost savings, which would make that price point potentially sustainable for ZAI.
Either way, it's clearly a strategic play to lure developers who need reliability without breaking the bank on inference costs.
For sure. And they seemed keen on transparency to build that developer trust.
How so?
Well, they released all the agent trajectories from their complex testing onto Hugging Face.
Ah, okay. So anyone can look.
Yeah, they're basically inviting researchers globally, Stanford, MIT, wherever, to reproduce the results, check their homework. That's a pretty confident move towards establishing credibility.
It is. Okay, so let's pivot to the practical side. For someone listening, maybe running a dev team, maybe a solo creator, where does this model actually fit in? What's the sweet spot?
Well, its versatility makes it useful for a lot of things, needing consistency and that big memory. Automating office tasks like generating really polished PowerPoints or complex reports.
Right.
Or building virtual characters for chatbots that need to stay reliably in character over long conversations.
And for developers.
Given the reported low latency and high quality on coding tasks, it's positioned as a potentially essential tool for remote teams. Cost-effective intelligence to help build things faster.
Okay, let's do a quick head-to-head then. Based on the source data, GLM 4.6 versus the main competitors, where does it clearly win? And where are the gaps?
The definite wins seem to be that real-world coding performance and the token efficiency. That 30% cost reduction plus the verified code output is its strongest suit.
Makes sense. And the weaknesses.
The main area where competitors like Claude still seem to have an edge, according to the reports, is multimodality.
Meaning?
Handling non-text inputs. So images, audio, maybe complex video analysis. GLM 4.6 seems much more text and code focused for now.
Fair enough. Seems like a deliberate trade-off, maybe. Specialize where you can win on cost and performance.
Exactly. And developer feedback seems to back that up. Some sources mention users finding it amazing for those routine, repetitive coding tasks where reliability is key.
Right, the bread and butter stuff where businesses often see the quickest ROI from AI assistants anyway.
Precisely. Nail those high-volume workflows, and you've got a solid utility proposition.
Okay, time for the reality check. No model is perfect. What are the big caveats, the challenges the sources flagged with GLM 4.6?
Well, starting with the tech side, hallucinations are still a thing.
Ah, okay. So even with this one?
Yeah, users testing it on really, really complex multi-step reasoning tasks reported it can still sometimes invent facts or generate code that just doesn't work.
So human oversight is still absolutely crucial.
Always. It underscores that we're not at full lights-out automation yet. Verification is key.
Got it. What else on the technical front? Hardware.
That's the other piece. Yes, it's efficient in token use, which lowers inference costs, but training and even deploying a model this large still needs serious hardware.
We're talking high-end GPUs.
Exactly. So while the subscription might be cheap, the underlying infrastructure needed, whether by ZAI or large users, isn't trivial. That limits true, unfettered global access in a way.
Okay, makes sense. And then there are the broader issues, the geopolitical climate, ethics.
Right. You can't ignore the context. Geopolitics is a big one. The ongoing tensions between the U.S. and China could definitely hinder wider adoption in Western markets, no matter how good the tech is.
A potential barrier regardless of performance.
For sure. And related to trust is data transparency. While they release the trajectories, some researchers want more detail on the actual data sets used for training.
To check for bias, reproducibility.
Exactly. Ensuring you can fully trace how the model learned what it knows. It's a standard concern with all large models, frankly.
And the environmental cost. Still a factor even with efficiency gains.
Absolutely. This is an industry-wide challenge. Even if token use is more efficient, training these massive models takes enormous amounts of energy. It's a major sustainability issue the whole AI community needs to tackle, something you see highlighted in IPCC reports on tech and climate impact, too.
So wrapping this up, it's been a fascinating deep dive. GLM 4.6 feels like more than just another model drop. It feels like a significant statement.
I'd agree. It signals that top-tier AI innovation is genuinely diversifying globally.
And its focus on efficiency, combined with that strong coding performance and the benchmark transparency, it makes it a really compelling option, especially for developers mindful of budgets.
Definitely. If your work touches on complex coding, professional writing, or building out intelligent agents, checking out GLM 4.6 on platforms like OpenRouter or Hugging Face seems like a worthwhile exploration. The shift it represents is quite profound.
It really underscores that innovation doesn't need a passport, just solid engineering and ambition. Which leaves us with a final thought, doesn't it? If these powerful digital minds are becoming so much more accessible and efficient, are we truly ready, not just to use them, but to fundamentally adapt how we plan, how we design, how we verify our work, to actively co-create with systems that are brilliant, yes, but also have these inherent known flaws we need to account for?
That's the crucial question for all of us going forward, I think. How do we partner effectively and safely with these new kinds of intelligence?